Alright, today we're going to take a look at section 7.1 and 7.2. Adding and subtracting polynomials, that's section 7.1, and multiplying, that's 7.2. Alright, we got a whole bunch of definitions here, so we'll go through these quickly. A term is a constant, a variable, or a product or constant of one or more variables, raised to powers. For example, 6. It says a term is a constant. There's a term, just a number. A term could be a variable, like x. Or it could be a product of a constant in one or more variables. So a term could be 3x squared, or it could be 5x squared y cubed. Those are all terms. A monomial is a constant, a variable, or a product of a constant in one or more variables raised to counting number powers. Okay, so all of the terms I wrote up above, they're also monomials. So let me give you an example of some things that would not be monomials. Some things that would not be monomials would be 5x to the negative 2, because the exponents have to be counting numbers. The exponents have to be 1, 2, 3, 4, 5. Another thing that would not be a monomial would be something like that had a square root in it. And the last thing, something like this that has an x on bottom. We're allowed to multiply things together, but we can't divide. We can't have fractions of x. Now, we can have fractions that are numbers. For example, 1/2 x cubed is a monomial. The numbers themselves are allowed to be fractions. What you can't have for monomials is x's in the bottom. Alright, a polynomial is a monomial or a sum of monomials. And I'm sure many of you have dealt with polynomials before, but it says a polynomial is a monomial, so it could be 3x. Another polynomial could be 2x plus 5. Another polynomial could be 4x squared plus 6x minus 9. Those are all polynomials. And we're going to study polynomials pretty much for the rest of this course this semester. So we'll be using these a lot. Okay, the degree of a term in one variable is the exponent of the variable. The degree of a polynomial is the largest degree of any non-zero term of the polynomial. Okay, so for example, back up here, this monomial, this has degree 1 because the exponent is 1. This one has degree 2 because the exponent is a 2. This one is degree 3 because it's got a cubed. Now, when I'm looking at a polynomial, I look at all the pieces and I pick the biggest power. So this polynomial, we would say this polynomial has degree 2. It's got the biggest power. When they have power 1, like this one, we call them linear, and that's because if we graph them we get lines. Degree 2 is called quadratic, so this one would be called a quadratic polynomial. Degree 3 is called cubic. And there's usually not a fancy name for things with bigger powers, 4th degree, 5th degree. Alright. A coefficient. The coefficient of a term is the constant factor of the term. Alright, so again, if I give you this term here, 3x squared, the coefficient is simply the number 3. If I have 5x squared y cubed, the coefficient is just the number 5. So for this polynomial here, this term, its constant, its coefficient is 4, and for this term, its coefficient is 6. So basically, you can think of coefficient as simply the number in front of the x. Alright, we're almost getting ready to start adding and subtracting polynomials. Like terms. Like terms are either constant terms or variable terms that contain the same variables raised to exactly the same powers. So, for example, 3x squared and 15x squared, those are like terms. They have exactly the same variables. They have exactly the same powers. If I had 5y squared and 6y, those are not like terms. They have the same variables. They both have y's, but they have different powers. And here's the whole deal with like terms. To combine like terms, we add the coefficients of the terms. So if I have two like terms, like 3x squared, and I want to add 15x squared, well, this is 3 things plus 15 things. I add them together, that's 18 things. Where here, if I had 5y squared plus 6y, I can't combine those because I've got 5 things, but then I've got 6 different things. The things don't match up. I can't add these together. That's the best thing I can do. If they're not like terms, you can't add them. Okay, so that's all the definitions, and that gets us down to what we're really going to do in this section, which is adding and subtracting polynomials. So, if I have 4x squared plus 3x squared, I notice that these both have x squareds. They're like terms. I simply add the numbers out front. That's 7x squared. And of course, this shouldn't surprise you. Part B, you're going to do at home. C, we add our like terms. So, we go through piece by piece. I know I have a 3x squared and a 6x squared. Those are like terms. 3x squared and 6x squared is 9x squared. I have a minus 5x and a plus 2x. Those are like terms. Minus 5x plus 3x. That's minus... I'm sorry. I was getting you the answer there. Minus 5x plus 2x is minus 3x. And then finally, I have just the numbers. I have a 2 and a negative 7. 2 minus 7 is 5. Alright, once again, D is for you. Subtracting polynomials. Subtracting polynomials really works the same way, except watch out for your minus signs. And this is the single biggest mistake. Now, I have seen over the years hundreds of students try to do problem E, just do it in their head without showing any work. And I'm going to tell you, probably 75% of them get it wrong. Okay? What I want to see is I want to see 2x squared minus 5x minus 1 minus 4x squared minus 2x plus 5. What I did is I took this minus sign and I distributed it. And if you take the minus sign and you distribute it first, your chances of screwing up your minus signs are much, much less. So I really want to see this. If you don't show this work and you mess up a minus sign, I'm not going to give you any credit, because I'm telling you right now, many, many students will get it wrong. Alright, now we combine our like terms. I have a 2x squared minus 4x squared. That's minus 2x squared. Minus 5x minus 2x minus 7x. And finally, minus 1 plus 5. That's a 4. Alright, F is for you. G. G sometimes will bother students a lot because it's got multiple variables in it. It really shouldn't. The rules are the same. In order to be able to add things, they've got to have exactly the same variables. So, for example, I have those two things as like terms. They both have exactly t squared in them. Since they have exactly t squared, I can put them together. 6t squared minus 4t squared is 2t squared. And then I notice I have some pieces that have two letters in them, t and w, but that's okay because they're the same. They both have exactly one t and exactly one w. They match. I can combine them together. That's going to be minus 7tw. And then finally, I have these two, but notice those two don't match. One's a w squared and one is a w. I can't put those together, so I'm just going to write them down. Minus w squared plus 3w, and that's the best I can do. And that happens sometimes. Sometimes when you go to add, you have some things that aren't like terms, and you simply can't put them together. Alright, H is for you. Once again, with H, notice we're subtracting. Distribute that minus sign through first. Write it down like I did. It only takes a matter of seconds, and your chances of getting the problem right are so much better. Alright, problem 3. It's giving us some function notation. It's giving us two functions. F of x is 4x squared minus 2x plus 8, and g of x is 7x squared plus 5x minus 1. And it's asking us to simplify f plus g of x. Well, f plus g of x means exactly what you might think it means. It's telling you, take the two things and simply add them together. And remember, when we're dealing with functions, this parenthesis thing here, this doesn't mean multiply. That parenthesis thing there simply means x is our variable. Okay? So we just write it down, and then we combine our like terms. We have 11x squared plus 3x plus 7. F minus g means to simply subtract the two things. So I'm going to take 4x squared minus 2x plus 8, and I'm going to subtract, so I'm going to have a minus out front here, and again I'm going to take that minus sign and I'm going to distribute it to all the pieces. So I'm going to write it all in one step here. I'm going to write minus 7x squared minus 5x plus 1. So I'm taking the minus sign and distributing it to all three pieces. Again, I go through and I combine my like terms. Minus 3x squared minus 7x and plus 9. Okay, well that was the hard part of these two problems. C and D, all we're doing is plugging in numbers. So for C, I'm going to take this answer that I got back up here in part A, and it's telling me take and plug the number 3 into there. So that's going to be 11 times 3 squared plus 3 times 3 plus 7. Let's see, 3 squared is 9. 9 times 11 is 99. Plus 3 times 3 is 9. Plus 7. 99 plus 9, that's 108. 108 plus 7 sounds like 115. Part D is saying take your answer from part B and now plug in negative 2. And remember my rule about plugging in negative numbers. When you plug in negative numbers, put them in parentheses. So we're going to have negative 3 times negative 2 squared minus 7 times negative 2 plus 9. And then we work it out. Negative 2 squared, negative 2 times negative 2 is 4. 4 times negative 3 is negative 12. Minus 7 times minus 2 is plus 14, and then plus 9. Minus 12 and 14 makes 2. 2 and 11, or 2 and 9, I mean, makes 11. Alright, 4, that's for you. Basically, you do problem 3 over again, except you have some different functions. Alright, so that was pretty much all of 7.1, and now we move into 7.2. 7.2, we're going to talk about multiplying. So we have a rule, definition, product property for exponents. If n and m are counting numbers, then x to the n times x to the m equals x to the n plus m. So let me show you what I'm saying here. I'm saying if I have x squared, and I'm going to multiply by x cubed, this rule is telling me I should just be able to add the exponents and say 2 plus 3 is 5. And here's why that works. X squared means to take x times x, and x cubed means multiply x 3 times. So altogether I have 1, 2, 3, 4, 5 x's being multiplied together. I simply add my exponents. Alright, so that's what we're going to use here in problem 1. If I want to take 5x cubed and multiply by 3x to the 8, I multiply the numbers. 5 times 3 is 15. And then x cubed means I would have 3 x's. X to the 8th would mean 8 more x's. 3 x's and 8 x's all together would make 11 x's. Okay? B is for you. C. C looks more complicated. It really isn't. Just more steps. We deal with our numbers. Negative 2 times negative 3, that's positive 6. X squared times x to the 5th. I add my exponents. 2 plus 5 is 7. And then my y's, y to the 4th, y squared. Again, I add my exponents, y to the 6th. We're getting close to the end. Last page. D is for you. E. How do I take something like a minus 5x squared and multiply it by a binomial, multiply it by something with 2 terms? I use the distributive property. So I'm going to take minus 5x squared and I'm going to multiply it by 5x. And then I'm going to take minus 5x squared and I'm going to multiply it by minus 3. And then I'm going to combine my like terms, if I have any. Minus 5 times 5 is minus 25. X squared times x is x cubed. And then minus 5 times minus 3 is a 15, and then I just have an x squared. Now, I'm going to be truthful with you. in most cases we probably wouldn't show all that much work. Here's really what I would expect to see if I gave you minus 3x squared times 4x minus 7. I would expect you to just go minus 3 times 4 is minus 12. X squared times x is x cubed. And then minus 3 times minus 7 is a plus 21. And then I still have the x squared. So what I'm saying is you don't really need to show this middle step where you do the distributive property. But of course you can if you want to, if it helps you. F, really no different, except you distribute to 3 things. So give that one a try. G. Alright, now, how do we multiply 2 binomials? To multiply 2 binomials, we do the distributive property twice. What we're going to do is we're going to start with this first thing, which is an x, and we're going to distribute it through. So I'm going to take x times x. X times x is x squared. Then I'm going to take the x and multiply it by the negative 6. That's negative 6x. Then I move to the 4. And I take the 4 and I distribute it through. That gives me 4x minus 24. And then I look to see if I have any like terms, and it turns out that I do. The 2 in the middle are like, so I put those together. Final answer looks like x squared minus 2x minus 24. Okay. I want you to try h, I, and j. And then k. K really isn't a big deal. It would help if you could see it, I suppose. K is just bigger. There's just more pieces, but we do it pretty much the same way. I start with the x, and I take the x, and I distribute it to all the pieces. That's going to give me x cubed minus 4x squared minus 6x. And then I take the 2, and I distribute it to all the pieces. That gives me a 2x squared minus 8x minus 12. And then you go through and you look for like terms. I see a couple. Final answer looks like it's going to be x cubed. I see this x cubed. I don't see any other x cubes. I see a couple things that have x squareds in them, so I'm going to put those together. Minus 4x squared and positive 2x squared is negative 2x squared. I see some things that have just the letter x. Minus 6x minus 8x is minus 14x. And finally, there's that number minus 12 floating all by itself on the end. Okay? No big surprise. That one's for you. Okay, our last problem. This is pretty similar to what we did on the end of the last page, where we added and subtracted. The only difference now is we're going to multiply. So f times g of x simply means take the f function and multiply it by the g function. Again, remembering that this x here on the end is just telling us that's our variable. That's not a multiply symbol there. We go ahead and we distribute. We have 6x squared minus 10x plus 9x minus 15. And I go ahead and I combine my like terms. That's going to be 6x squared minus x minus 15. And part B, this symbol simply means take the answer that you just got and plug in negative 2. When I plug in negative 2, I'm going to have 6 times negative 2 squared minus negative 2 minus 15. Negative 2 squared, that's 4. 4 times 6 is 24. Minus and a minus becomes a plus. 2 minus 15. 24 and 2 is 26. 26 minus 15, 11. Alright, problem 3. That one's for you. Okay, I know I went through all this pretty quickly, but having taught this class for a long time, I know that most of you have seen this before. Most of you are very good at adding and subtracting polynomials and very good at multiplying. So I hope this looks familiar to you. I hope it went okay. Of course, if you're having problems, send me an email or ask me about it in class.